My name is Michał.
And my name is Bartek.
And we are ops team in Syncano company. We'll be talking today about automating microservices. Syncano is a Norwegian startup, but we are distributed. Whole engineering stuff happens in Warsaw. Headmasters pushes button in Oslo, but because of our target, customer growth is located in NY. What we built is platform for front-end and mobile developers, helping them create API. Similar products are called backend as a service. Syncano is quite complex product containing data storage. Users can create classes and objects and store them in our Postgres database. Also code execution. We provide sandboxes with different runtimes, allowing user to run code and create triggers for webhooks and actions on objects. And the whole thing user create can be packed, version tagged, and stored in our market for other users to create, to benefit from. When we joined the company in April this year, the product architecture was completely shaped. There were 2 VPCs for staging and production. Backend app was split in 3 elastic beanstalk environments. They were auto-scaled based on machine load. Load balancer was set up. We had continuous integration server and some third-party services like log entries for centralized logging and querying, messaging queue, RabbitMQ as a service, also Datadog. Sounds good. But in terms of reliability, there are some points missing, and what is missing, and well, quite crucial points. It's high performance monitoring, collecting metrics, for example, for debugging performance issues, some serious orchestration, and regular load tests. As Conway's law states, organization creates system that reflects its communication structure. So it's quite natural for Syncano to build microservices. Our services are clearly separated by business logic. We have small services containing separate processes communicating via messaging queues, and in terms of third-party services via API. They are deployed separately, and the management is decentralized. But it's not the reason we built microservices. If you read the blog post on Circle CI, you know what's the main rule of building microservices. Don't build microservices first. Actually, it's a 4th version of our product, but first publicly released. So the architecture, it's not just the golden shot. We had separated front-end, back-end, and databases, also third-party services. But backend is split to 3 environments: web app, workers, and code boxes where we run user code. They are deployed separately. The deploy is asynchronous, so are rollbacks, and they are scaled separately. So we can provide different redundancy factors, which improves availability. How about programming languages? Because we use microservices, we can implement different parts of the system with different programming languages, like in our case, Python and Golang. Because we know there is no silver bullet and we have to match task with the case. How about third-party services? In someone's delivery service we need, and well, they perform better than we currently do. Because of modularity of our platform, we can just plug in third-party services, and when we will be ready, we can switch to self-hosted versions. It's just a matter of time. Sweet, but it's not free. And in real life, microservice architecture bites several times. So it's better to prepare for something. Microservices come with huge complexity boost. They are harder to implement and harder to debug than monoliths. Sometimes it's not just trivial to plug into your code with debugger. Also, if you don't want to lose your hair, you have to take care of provisioning and deploy. The faster, the better. Also, at least basic monitoring and automation everywhere. Microservices also demands from your organization DevOps culture. And how does it DevOps culture looks like in our case? Ops team works with developers. We apply agile methodology and practice Scrum. What we do is implement it with Ansible in domain-specific language. So we store it in files. Can we version them? Of course. And well, we can improve them, and can there be bugs? So we can easily treat it as a code. In Syncano, we have separate GitHub repositories for every product. It's the same in our our infrastructure configuration. So we organize our work in sprints and decompose tasks into features, release them as soon as possible, and practice code review. How about testing? It's, well, still in progress in ops field, because running tests of our configuration demands running on hosts and also some separate checks, for example, for services, if they are up for a specific time frame. Currently, during continuous integration builds, we run syntax checks for Ansible playbooks, and also code quality checks for scripts that are in our project. Furthermore, documentation. Not the easiest one, and possibly the most boring, but darn important if you want to keep knowledge about your product updated, not necessarily in someone else's head. So we keep a version wiki where crucial parts of the system are described. Our way to the automation was marked with decisions already made by developers that worked on the system before us. Because of Bartek's experience with our Ansible, we picked this tool to orchestrate provisioning and deploying of monitoring machines, then plan to moving whole infrastructure configuration to Ansible, which is still in progress. Deploy is made in Elastic Beanstalk Autoscaling environments, and developers picked Docker as app containerization format. It's, well, decision mostly forced by using Elastic Beanstalk. We had Circle CI for continuous integration, well, mostly because of clear configuration format and support for Docker. Our monitoring is quite tricky. Bartek proposed using SunCloud's Prometheus and for collecting metrics, and Isinga 2 for checking hosts and services health. But first, let's talk about Ansible.
Yeah, this is my part. So, as you know, we are orchestrating our environment with Ansible. And why we choose Ansible, the first reason was I knew already Ansible for some like more advanced tasks. So I decided to create some new thing, and it's kind of a mixed inventory. So our Ansible inventory is based on two things. The first thing is the dynamic inventory, that is basically Ansible external inventory for Amazon. And based on this dynamic inventory, we are creating static files, called the static inventory in this case. And in these static files, we are defining our infrastructure, our groups, our servers, based on the information that we have from the dynamic inventory. So in this combination is quite of a nice thing, because each Ansible run you have fresh and actual information about your whole environment. As you can see also, we are splitting our inventory to production and staging. So we are using two different kind of group vars. And together with playbooks and roles that we already created, we can do things like autoscaling, like provisioning, and some other things, monitoring mostly. So this is how our inventory looks like. So let's go to autoscaling. As Michał said, we already are using Elastic Beanstalk together with Docker. We based our autoscaling methods about metrics. Metrics on the lower level. On the higher level, we call them triggers. So basically, when there is a circumstance that occurred in the infrastructure, for example, the CPU load on the specific node or scaling groups hits the limit, it starts auto-scaling itself. We are configuring our environments with AB extensions. Those are Amazon YAML files that are maybe a little bit dirty for us. That's why we are moving the whole philosophy from those YAML files to Ansible YAML files, and we'll be executing them across each node that is created in a group. We also created some custom software agents to take care of some critical parts of our platform. Those are mostly Python-based applications. As for scaling, we did some work to put our own metrics to CloudWatch, and based on those metrics, we can scale our environments in appropriate time, and we can do it in the right way. Yeah, we use Docker. It's like a popular thing lately. Why we use it anyway? The first thing is that it's the open platform for distributed applications that allows developers and administrators to build, ship, and run applications anywhere you want. Of course, it's based on Linux. We use Docker because it is light. So basically, the containers are running on the same hosts, are using the same kernel, so they start almost immediately. It's only a couple of milliseconds, and during this, it's also the RAM usage is better, and this way. We use Docker together with Elastic Beanstalk. Basically, the Elastic Beanstalk, we deploy our application through a Docker container. For a moment, we are using a single Docker container for deploying applications. Using Elastic Beanstalk is a very, very nice thing because it takes over all your work you have to do with provisioning, with load balancing and scaling, and this is the hardest part. And it provides a way to for the application to be more reliable, because when you kill a container or the container will, I don't know, blow up, the whole Elastic Beanstalk will start another node or just spin up another container. So as for the containers, how we store them, as most of people, we are using some third-party software to do that. First, we had Docker Hub, but there was like Docker was more popular from day to day, so the Docker app had some issues. So we moved to Quay. That is the core OS thing. You can also store your images in Google platform or in Docker Hub. As for Docker registry, there is a new version, and we want to implement the registry 2.0. So the main change for this is that we will be able to pull and push images to the repository in a more safely way, because I don't know if you know that this repository that functions right now is not so safe. So in the near future, we want to create our private repository to host it inside our infrastructure. And we need the repository to keep track of the version, because Docker containers or Docker images are basically snapshots of in current time of the whole storage volume. So the set of layers is giving us some pretty cool possibilities, because we can reuse some layers in some different containers, for example. And as we are building application stacks, so we are using Docker containers more widely, because we have containers for code boxes, for web nodes, for monitoring, for developers' use. So it's pretty easy to work with it. The images that we are creating, we are trying to do the Docker best practice. So we are keeping the layers in a very little number. And we are trying to version it with our own way to be able to provision it and build the application faster. And it's giving us also a pretty easy way to roll back any change that we want. So for us, Docker has a bright side and a dark side. So from our experience, the bright side is like the deploy code is easier, and the rollbacks are pretty easier as well. Easy to orchestrate. For example, in Ansible, you have a core module that is responsible for spawning Docker containers. So it's also a pretty easy thing to do. You can run your applications anywhere, almost anywhere. Yeah, DevOps like Docker, that's an obvious thing. And Docker has a nice API where you can connect and do some stuff when you're creating some custom solutions. The dark side that we felt mostly is like during the provisioning, sometimes Docker daemon becomes dead. So this is one of the problems that we had. Another one, that having a big infrastructure based on Docker, you are starting to having trouble with debug, and troubleshooting it is kind of a nightmare. But when you use sysdig, it's obviously better. The networking in Docker is kind of a primitive. As far as I know, in version 1.9, there will be some new things about networking. Yeah, the registry that we used had issues like concurrent downloads, timeouts. So this was a pretty big problem, especially when the registry is a part of your pipeline. And layers, as we are executing many sandboxes, so they are leaving some garbage behind. So you have to be aware of that and clean it from time to time. Okay.
Docker. Well, Docker is fast when you run it, but well, building image, not so fast. But it simplifies build pipeline. So this is how our app is built. When we push feature branch to GitHub repository, it triggers build in Circle CI. We run Docker Compose tool to rebuild app image, and then recreate the infrastructure where we run our test suite. So, well, the results are clearly visible for the whole team. Deploy, well, happens pretty in the same way, but after merging to staging branch, again, build is triggered in Circle CI, but instead of running tests, we push the created image to our Docker registry. Then Elastic Beanstalk pulls this image and deploys to EC2 instances. We perform rolling deploy, so we don't kill old containers until the new one passes health checks.
Yeah, now a few words about our monitoring systems. We are using only our own tools made from blocks, essentially. I must say the whole monitoring subject as for autoscaling environments is kind of a hard thing because you are landing basically with lots of notifications about things that are going on in your infrastructure. So we decided to keep things simple because it's the first design of the monitoring for our platform. We decided to go with Prometheus as for graphing and metrics collecting. It's a SoundCloud tool written in Golang. So it's fast, it's also Docker friendly, but let's talk about it on the next slide. So basically, we have few VPCs and few environments that are basically a mirror copy. So we had to think about moving our monitoring to some automated way. And we created a solution that is fully automated. And the thing that we are doing right now is mostly tuning the notifications. But more about here. Why we use Prometheus? Because the first of all, it has a spread architecture, so it contains many small components. So it's easy to scale, it's easy to connect, and it's pretty straightforward. All the data is multidimensional. So, and Prometheus is keeping it in a time series database. So it's kind of a different thing than the most tools I know. It has a flexible query language. That means that when you have all your metrics written or collected, you can you can create a specific query to find a thing that, I don't know, you're looking for. Also, there is a very nice graphing module that from Prometheus, and it's called PromDash. And we are using it widely. Also, Prometheus config files are pretty easy to orchestrate, so you can easily generate a config to Prometheus from Ansible, Chef, or Puppet. We also use Isinga, like a pretty standard Nagios based software for mostly monitoring for monolith, for static environments. But we also use Isinga because the new configuration layout is better. It's more flexible to build some specific monitoring checks, to send notifications. You have templates. You have some new cool features, and in the future we want to create a cluster, because right now we have like separate server for each environment, and we have like a couple of ways of notifying. But in the future we want to do it on the larger scale, and we want to scale it up. As for monitoring itself, like integration point, so we created a piece of software that is basically an HTTP endpoint, and our elastic beanstalk environment, each information that is coming out from the Autoscaling group is going to a short notification system that is a service from Amazon. And from the Amazon SNS, you can forward those messages to your email account or just to a HTTP endpoint. We use this endpoint to basically run Ansible. So when the information comes from Autoscaling group to SNS, hitting the HTTP endpoint, it's basically generating locally on the monitoring server all the config files for Isinga, so all the host files with services and all the things that we want to monitor is already in the config files. And in the same time, we are generating a Prometheus config. So we have the whole configuration in place. And as for the nodes in the Autoscaling groups, they are basically the agents that we are using, because Prometheus and Isinga use agents. So the agents are already there. So the drift between creating a machine and sending a notification is about 7 minutes. So yeah, this is our solution, and we are. Our notification system is basically mostly based on Slack and emails. So this is how we monitor things.
So a few words to finish about our plans for the future. We successfully run continuous integration, but we'd love to have continuous delivery and automate every repeatable task. But we want to stay responsive to developers' need. First of all, Docker makes builds and deploys too slow for really hot fixes. Isinga checks don't really work well with autoscaling groups, so we want to tune it to avoid flapping during autoscaling. Also, it would be great to have real Ansible playbooks tests and checking how our code influences performance. Also, if you grow as a company, we would like to be provider independent to move to any other ES or to self-hosted machines, or also because of our third-party services user experience, we'd like to move to self-hosted versions. Lots of details, but if you had time, we'd like to answer some questions of you.
Okay, we have 2 more minutes just for the questions. Do you have any questions? Oh, there's one question in the back.
Hi, in your environment you use Docker philosophy, one process, one container, or you have some advanced other techniques that you are simulate init or something like that?
Actually, the philosophy is up per container.
No, one process. It's Docker philosophy. On the website said one process, one container. So what's your solution?
No, our solution is up per container.
So you have more than one process per container, yes?
Yes.
Sometimes.
Do you use init or something like that, or you use only spawning application process in the containers?
Well, we use spawning by bash script.
Okay, and one more question about networking. You on the slide it was said that Docker networking is primitive. So my question is, do you ever try use Docker with Open vSwitch as the something extended the normal networking?
Yeah, it's a fresh subject for me, and I'm still developing a thing with Docker. The thing is that Elastic Beanstalk and Amazon environments is forcing us to use older versions of Docker. And for example, I don't know how many of you tried to execute Docker on multiple bridges or on 2 or 3 interfaces. Like you said, you can use Open vSwitch, Wave, or some paper trail or something like that.
Paperwork.
Yeah, paperwork, exactly. But for us, it was some kind of overhead because we are trying to do some separation as for Docker. So we want to separate the code, the sandboxes that we are running on our platform from our infrastructure. And this was kind of a hard thing because you are landing in a situation that you have 2 solutions. The first one is executing Docker from inside of the Docker or having 2 Docker daemons. So networking after version 1.9 has the support for multiple bridges, interfaces, and
because I have already done integration Ansible and Docker and Open vSwitch, it's working very well.
Yeah,
so it's
But on Elastic Beanstalk?
No, it's my own solution for my company.
Because paperwork doesn't work.
No, I use if you use Open vSwitch, they deliver in the master branch, then they deliver special script calls over Docker when you can use seamlessly integration. So I extended Ansible to use this script and it's working very well. So maybe in your solution will be something it's worth it to use it.
Okay. I suppose you needed a connectivity between Docker containers on multiple hosts. That's why you needed Open vSwitch. Our containers are living mostly 30 seconds is the maximum time. So the code that is executed inside of the code boxes, even if it's over 30 seconds, the container will be killed. So basically, we don't need connectivity. So I was trying to keep it simple and use mostly Linux tools and created some specific routes for some specific things. But we can talk about it after the presentation.
Exactly. And the backstage, one more question, short one.
Did you ever consider using just Elastic Beanstalk without Docker? And if yes, what kind of problems Docker solves for you? Because Elastic Beanstalk is somehow also unified environment.
Yes, but Elastic Beanstalk, makes it harder to put the software configuration you'd like to have. So Docker is just a package for our app.
Yeah, the container that is spinning up with the node has all the information or the configuration and basically all the code from the application that we want to deploy.
One more. Okay.
Because Elastic Beanstalk is just exactly that. It's a package of software with configuration that is external and per Elastic Beanstalk environment. So what other thing solves you Docker?
So we use Docker for executing sandboxes. So when Amazon is spinning up a Docker container with our application, we can, from this application, connect to the Docker API and spin up another containers. This is what we are using it for.